using synthetic division to write it in this form. We're going to take the 1/3, because that represents our r value here. We're going to stick it in the box. We're going to spell out the coefficients on the polynomial function, making sure each term is accounted for. In this case, no zeros are necessary, right? Set up our line, set up our box here for our remainder. Going through the synthetic division, bring down the -6. I take -6, I multiply back to the 1/3 in the box. 1/3 of -6 is -2. I add through the -10 and the -2, I get -12. Multiply the -12 back to the box, so that's 1/3 of -12, which is -4. Add through, get 9. 1/3 of 9 is 3. -5 and 3 is -2. So if I'm trying to spell out this form where p of x equals x minus r times q of x plus p of r, how that form's going to look, we'll start with x minus r. R is given as 1/3, so it's going to be x minus 1/3. Q of x is our quotient here. So here's the coefficients that make up that quotient. We started with a power of 3 here, degree 3, so we're going down a power now for that lead coefficient. It's going to be -6x squared minus 12x plus 9. All of that makes up the quotient. And then we add on this p of r, which is the remainder idea. So to add on that remainder idea, we're just going to subtract 2 away. So new function here, new proposed root. With the new function, we notice that some terms are missing, but as far as the root's concerned, or proposed root is concerned, that 3/4 goes in the box. Spelling out the coefficients on the function, we start with 64. That goes with the x cubed term. There's no x squared term, so I need a 0. There's no x term, so I need a 0. I do have that constant, though, of -25. So set up my line, set up my remainder box, go through the synthetic division. Bring down the 64 to start. All right, we're taking 3/4 of 64. So basically to do that, I could take 4 into 64, which is 16. Take 3 times 16, that's 48. Add through, get 48 here. Now I'm taking 3/4 of 48. So take 4 into 48, that goes in 12 times. 12 times 3 would be 36. 36 goes in the next column. If you add through, get 36. We're taking 3/4 of 36. So 4 goes into 36 9 times. 9 times 3 is 27. If we add through now in the last column, we get 2 back. So putting this in the form that we're asked for up here, we've got x minus r. X minus r is going to be x minus 3/4. We've got our quotient. Our quotient comes from this little collection of coefficients right here. We started with degree 3. We're bumping down a power now on that lead coefficient of 64. It's going to be 64x squared plus 48x plus 36. There's your quotient piece. And then tack on your remainder. Your remainder in this case is 2. All right, x minus 1. Is that a factor of this polynomial? The way we're going to figure this out, do a little synthetic division. If x minus 1 is a factor of this polynomial, we should be able to take that polynomial, divide by x minus 1, and get a remainder of 0, right? So if we're dividing by x minus 1 using synthetic division, we can place a 1 in the box. All right, it's x minus 1, so just change the sign on that 1. 1 goes in the box. Spell out your coefficients on the polynomial. Make sure every term is accounted for. We set up our line here, set up our remainder box. If the answer to this question is going to be yes, we need a 0 right here, right? That's what we're looking for. So doing the synthetic division, bring down the 2. Multiply back to the box with that 1, get 2. Add through the next column, get 3. Multiply back to the box, get 3. Add through, get 7. Multiply back to the box, get 7. Add through, get 0, which is what we were looking for. Is x minus 1 factor this polynomial? Yes, it is, because the remainder is 0. And basically what we're trying to do here is we're trying to solve this equation knowing one of the solutions is 4. So knowing one of the solutions is 4, we could take that 4, this given root, we could put it in the box for synthetic division. We could put it in the box because that represents the factor of x minus 4, which we would be dividing into this polynomial. So now I'm going to spell out the coefficients on the polynomial, making sure every term is accounted for. Because this is given as a root, our remainder is going to be 0. So going through doing the synthetic division, we get 2 here, multiply back to the box, get 8 here. Add through, get negative 1. Multiply back to the box, get negative 4. Add through, get negative 1. Multiply back to the box, got negative 4 there, checks out that we get 0. Now if you're wondering why we're going through the synthetic division, already knowing this is a root, well, since we're trying to find the other roots or other solutions to this equation, we have now divided the factor of x minus 4 out, and we're left with this quotient of 2x squared, because we're going down 1 in the power, minus 1x minus 1. We've divided that x minus 4 factor out, and we can take what remains, set that equal to 0, and solve. So we're left with a quadratic here to solve. We try factoring it out, and we can appreciate that if it doesn't factor out, we could always use the quadratic formula as well. Try factoring here. Looks like it's going to work, right? So you take your 2 factors, set each factor equal to 0, and solve. Over here, x is going to be 1. Over here, I'm subtracting 1 and dividing by 2, so x is going to be negative 1/2. 4 is a rational root. We've got to find the others for this equation. The others would be these 2 solutions right here. So similar scenario, basically trying to solve the equation, already knowing one of the answers is 1/2. Just like we did on the last one, take that given root, that given solution here, put that in the box. Spell out those coefficients for your polynomial that equals 0 here, making sure each term's accounted for. Because 1/2 is a root or solution to this equation, we already know the remainder is going to be 0. We're just trying to break this down to, in this case, a quadratic that we can solve for to get the remaining roots. So I bring down the 6. I take half of 6, which is 3. Add through, get 10. Take half of 10, which is 5. Add through, get negative 4. Take half of negative 4, which is negative 2, and checks out that I get 0 back. So what we have here, again, because we started with degree 3, we're now down to degree 2. This would be 6x squared plus 10x minus 4, which I can now set equal to 0. I can do that because I've divided by this factor of x minus 1/2, and 6x squared plus 10x minus 4 remains. Okay, solving this. Once again, factoring is a possibility. There's the greatest common factor of 2 we could take out to try to make this easier. And taking out that 2, because there's no x attached to that 2, we can divide out the 2 from both sides. So what remains is 3x squared plus 5x minus 2. If I try to split that up, now let's see, I've got 3x times x. I space this out where it's 1 and 2, right? Outer loop here is 6x. That needs to be positive. Inner loop of 1x. That needs to be negative. That'll check out to get that 5x in the middle. So you've got 3x minus 1 as a factor you can set equal to 0 and solve. And you've got x plus 2 as a factor you can set equal to 0 and solve. For x plus 2, we get x equals negative 2. And for 3x minus 1, if you add 1 over and then divide by 3, x is 1/3. So our remaining solutions to this equation, knowing that 1/2 is a solution in the first place, or our remaining roots, is 1/3 and negative 2.